Okay, class, today we're going to work on trig functions of any angle. So the definition of a trig function of any angle is you have an angle theta, which is drawn here, in standard position, and r is going to be the length of the terminal side of the angle theta. So here is my terminal side, and if I have a dot at the end of it and say that's the length, this is going to be my r. And then what I'm going to do is I'm going to draw a little triangle with the x-axis where r is going to be the hypotenuse of this triangle formed. So if I'm going to want to find sine of the angle theta, which is this angle in standard position with the terminal side of length r, I'm going to drop a perpendicular from that terminal point down to the x-axis, and we're going to form a little triangle, and we're going to find sine of this little angle inside the triangle. And that's what we're going to do when we have all angles. Okay, so in example 1, it says you have a point 2, -4, so I'm going to draw my axes since I know it's going to be on the terminal side of an angle in standard position. And if I go over 2 and down -4, that point I plot, just think algebra 1, I plotted that point right there, over 2, down 4. So this is going to be the terminal side of my angle. So I started in the positive x-axis, and we're always going to go in this counterclockwise position. So that's the angle. So what we're going to do is we're always going to draw a perpendicular to the x-axis, and we're going to look at this right triangle here. And I'm going to call this angle right here in standard position my angle theta. So we're going to call this angle here theta. The hypotenuse is what we're going to call r. And of course, since I went down 4, I know that going down for my triangle, that's -4. So if I just pull out my triangle, where this is a right angle, this was 2, this is -4, that was my r, and my angle here is theta. Okay, so we're going to find the exact value of sine, and I know that sine is given as y over r. So my sine of theta is y over r. So my y, well, that's the y coordinate. That's my -4. That's my y value. So I know that's -4. My r is my hypotenuse. Well, this is a right triangle. I can use the Pythagorean theorem to find my value of r. So I know my r squared, my hypotenuse, is the other two sides, 2 squared plus -4 squared, or r squared. Oops, excuse me. My r squared is 4 plus 16. And when I add 4 plus 16, I get r squared is 20, or in other words, r is the square root of 20. Remember, square roots need to be reduced. 20 is 4 times 5. When I take the square root of 4, it's 2 square root of 5. Okay, so all of that was just to find r, the length of the hypotenuse of my triangle. We ultimately wanted to find my sine. So sine of theta was y over r. Y was the y coordinate, which was -4. My r is 2 root 5. We can never leave a radical in the denominator, so I'm going to rationalize by multiplying by root 5 over root 5. So when I multiply by root 5 over root 5, I end up with -4 root 5 on the top. And in the denominator I have 2, and then root 5 times root 5 becomes 5. So 5 times 2 is 10. Now my 4 and my 10 are going to reduce, and I get -2 square root 5 over, when I take the 2 out of both of those, I end up with a 5. And that would be my final answer. Okay, let's move on. Okay, so likewise, we're going to have a point -24, 10 on the terminal side of an angle in standard position, and we're going to find the exact value of secant. So if I start in standard position at the origin, I go, left 24, -24, and up 10, I have my terminal side up here. of my angle, which is in standard position. R is the length of the terminal side, so I can go ahead and solve for R using the Pythagorean theorem. Okay, so I went ahead and set up the Pythagorean theorem. R squared, the hypotenuse, is negative 24 squared plus 10 squared. When I take the square root of that, I get 26. So I now know that the hypotenuse is 26. I want to find secant. Secant is given as R over X. So I have secant of my angle theta is R over X. My R is 26. R is 26, and my X is the X coordinate, which is negative 24. So I have 26 over, we can go ahead and reduce this fraction, and I get negative, when I divide both of them by 2, I get 13 over 12. So since we were asked to find secant, which was R over X, I had my R of 26 over my X, which is negative 24. I reduced my fraction and end up with negative 13 over 12. Let's go ahead and move on. So for example 3, we're asked to state in which quadrant theta lies if secant of theta is a positive number and cotangent of theta is a negative number. So secant, I remember that secant is going to be my R over my X, and my cotangent is my X over Y. So what we're going to do is we're just going to think about what quadrants these could possibly be. So secant is greater than 0, which means it's a positive number, and cotangent is less than 0, which means it's a negative number. So I know I have a positive number and a negative number. So secant is positive, cotangent is negative. So we have to figure out which of our 4 quadrants, 1, 2, 3, or 4, theta is in. So I know R over X is a positive number. Well, R is the hypotenuse of our triangle, and it's a length. R is always going to be positive 100% of the time. So since R is always positive, it's our X and our Y's which can be negatives. So I know R is positive, so if this ratio R over X is going to be a positive number, X needs to be a positive number. And X is positive over here in quadrants 1 and 4. So I know that secant is greater than 0, means I need to be in quadrant 1 or quadrant 4. On the other hand, cotangent's a negative number. So for cotangent to be negative, I have the ratio X over Y needs to be negative. Well, if you have a fraction, if you have a positive number over a positive number, then your fraction is positive. So I know X and Y can't both be positive. And likewise, if they're both a negative number over a negative number, if X and Y were both negative, a negative over a negative is a positive number. And I want a negative number. So the signs have to be different. So either my X is positive and my Y is negative, or my X is negative and my Y is positive. So the 2 quadrants where the signs are opposite are in quadrants 2 and quadrants 4, because remember in quadrant 1 both X goes in the positive direction and Y is in the positive direction, and then in quadrant 3 your Y goes in the negative, your X goes in the negative and your Y goes in the negative, so the signs are different. So for cotangent to be negative, I know I'm either quadrant 2 or quadrant 4. So quadrant 2 or quadrant 4. So since I need both of these things to be true, I know that the overlap is in quadrant 4. So my reason is quadrant 4 is where both of those make theta true. Okay, let's go on to example 4. Okay, for this one I am given that cotangent is undefined and my theta is between pi over 2 and 3 pi over 2. So what I would like you to do is pause so that you can pull out the unit circle, and we're going to look at where pi over 2 and 3 pi over 2 are located on the unit circle. So I have pi over 2 up top and 3 pi over 2 down on the bottom. So my theta is bigger than pi over 2 and less than 3 pi over 2, which means it's over here in quadrants 2 or 3. So I know my angle is over there because it's somewhere between or equal to pi over 2 or 3 pi over 2. But I also know that cotangent is undefined. So cotangent, if you recall, is x over y. So for something to be undefined, it means that you are dividing by 0. So that means that y equals 0. I don't know what x is, but I know that y equals 0 because for something to be undefined, you're dividing by 0. So if my y equals 0, looking at your unit circle, of all the places where the coordinates are y equals 0, I know I have one where I have some x coordinate and my y coordinate is 0 at the angle pi. So I know that my theta needs to be pi. It's also true that cotangent is undefined over here at the angle 0 or 2 pi, but that is not a number between pi over 2 and 3 pi over 2. Pi meets the criteria that it's bigger than pi over 2 and less than 3 pi over 2. So for part A, we wanted to find sine of theta, and remember sine is y over r, and my r on the unit circle is 1, and my y coordinate is 0. So my y over r is 0 over 1, which is 0. For B, we wanted to find cosecant of theta. So our cosecant of theta, remember cosecant is the reciprocal of sine. It's also known as r over y, but it's just the reciprocal. My r was 1 because it's the unit circle, since I'm getting my numbers off the unit circle, and my y value is 0. We can't divide by 0, so I know it's undefined. So I'm going to write the answer is undefined. Okay, and that's all for this lesson. There is another part of this section, but this is all for tonight. So have a good night, and I will see you later.